Consider Z1 is 2 plus 2i and Z2 is negative 3 plus 4i. In examples 1 and 2, we've found out the modulus and the argument for each of these. We want to plot them on the polar grid below. Now, so a polar grid here, the circles represent a constant distance from the origin. So if we look at the circle that goes through 6, any complex number lying on there will be a distance 6 from the origin. And then we have these angles like so. And these are at 15-degree intervals. So 15 degrees, 30 degrees, 45, 60, 75, and then 90 when we get onto the imaginary axis. So if we think about Z1, 2 root 2 is the modulus. The square root of 2 is about 1.4. So that's going to be approximately that. So that's going to be approximately 2.8. Now on here, we'll make that just before the 3 ring. And then the argument of Z1 is pi by 4, which is 45 degrees. So we're going to have to plot that one about here. Like so. So here's Z1. The modulus for Z2 is very easy, so 5, so it's going to be on the 5 circle somewhere. And the argument is 2.21 radians. So 2.21, let's multiply that by 180 and divide by pi, and that gives me 126.7 degrees. So if we're looking at our diagram here, 90 degrees, 105, 120, and then the next one's 135, so it's going to be somewhere between these two. So let's say it's about here. I'm just going to do that in a different color. So we'll say it's about there. And so that is Z2. So we can represent complex numbers in a polar plane like this as well. And for certain complex numbers, that's just as easy as doing it on the rectangular plane. And there are advantages to working with complex numbers on the polar grid rather than the Cartesian grid.